Good morning. My name is Fred Johnson. I'm going to do a presentation on surface water quality, non-point source pollution impacts to the Navajo Nation, stream, rivers, and lakes. Again, I'm with Navajo EPA Surface and Groundwater Protection Department Water Quality Program / NPDES, Fred Johnson, and I'm an environmental specialist. Our program received authorization from US EPA in 1993 under Section 106 and 518 of the Clean Water Act to implement a water pollution control program. Clean Water Act, its main objective is to restore and maintain the chemical, physical, and biological integrity of the nation's water. Its goal is to eliminate discharges of pollutants into surface water. Another goal is to achieve a level of water quality which provides for the protection and propagation of fish, shellfish, and for recreation in and on the water. And then Navajo Nation, we have our own Navajo Nation Clean Water Act. And this Navajo Nation Clean Water Act allows our program to, gives us authority to regulate discharges into the waters of the Navajo Nation. Discharges refers to dumping out, pouring out, or leaving stuff behind. It also gives us authority to implement a national pollutant discharge elimination program, gives us authority to implement clean lake programs, also allows for implementation of water quality standards. This is just a photo that shows the skies at night, and we humans, we don't really think about it all the time, or sometimes most of us probably forget that the earth that we're on is out there in space as well. So this is just a reminder that the planet we're on is in space. Picture of our Mother Earth. In Navajo we call it Nihimana. And then this is just a drawing of a lady and a man hugging, dusting, loving our Mother Earth in Navajo. And we say Mother Earth, we say Nihimana Hastan. And this is a map that shows the map of the Navajo Reservation, and it extends into Utah, Arizona, New Mexico, none in Colorado, and the size of the reservation is approximately 25,000 square miles or 19 million acres. And then the other smaller polygons you see within the Navajo Reservation, these are delineated watersheds within the reservation. So the biggest watershed that we have in Navajo is the Chalco, on the New Mexico side is the Chalco watershed. This whole area is a Chalco watershed, and that extends to Chalco, Crown Point, Tohatchi, Sonosti, coming off of the Chuscas, and all that drains into the San Juan River, and then down into Lake Powell, through the Grand Canyon to Lake Mead, and then goes south to Lake Havasu, and eventually it used to make it back into the ocean, but it doesn't now. The biggest watershed in the Arizona side is the Chinle watershed, and that extends from Crystal, Ganado, Burnside, all the way, flows up north off of the Chuscas, Cottonwood, Cayenta, all that drains again into the San Juan River. And then we have the satellite reservations, Rama, Alamo, and Tohajale. And then this southeastern part of the reservation, water flows off, and that flows off drains into the Rio Grande. So that's where our waters go after it leaves the reservation. Next. And then this is just a picture that shows a raindrop bicycling, but this is just to ask the audience if this is the water cycle that they know of or they learned about in school, but it's not. It's just a raindrop mountain biking. Next. And then this is a drawing of the watershed, and not the watershed, the water cycle. So the main thing that allows water to function on land and how it leaves the land and goes up into the sky, and then it comes back down is solar energy. Without the sun, the water cycle is not going to function. So when the sun comes out and it heats up the water bodies, And when it heats it up enough, the water changes from liquid to vapor, and evaporation happens, and the water travels up into the sky, and that turns back into clouds, condensation, and then from the clouds we get precipitation, water coming out of the sky back on land. And when it gets on land, some of it goes into the ground, infiltrates and recharges groundwater. Some of it runs off land, goes into lakes, streams, and some of it the plants uses to grow. So that's the water cycle. But the part of my presentation is going to cover the surface water runoff portion of the water cycle. During surface runoff, surface runoff occurs when you get rain or snow, and when the snow melts to where the soils are saturated, and there's more water coming off the land, and that's when the water starts to flow off land. That's the runoff. But during runoff, we don't really realize it, but during runoff we have the more water running off, the stronger it gets. So it's gonna move stuff off the land. It could be pollution, trash, and it could be even by erosion. Water moves soil off land and carries that into your stream, rivers, and lakes, and that's how runoff contributes to generating a pollution called non-point source pollution, and that gets into our stream, rivers, and lakes. Next. And this is a photo of the San Francisco peaks. From a distance, you look at a picture like this, you know, it's really nice, it's beautiful, but what we don't see in this area, in the forested areas, are activities that we can't see from far away. Like there could be logging going on, there could be illegal dumping, there could be construction, people camping, people hunting. So those activities we don't see, or any of the negative impacts from activities happening in this mountain we don't see from a distance. But when you get in there, you know, you start to see all different activities that you don't see from a distance that could be impacting the environment or watersheds or even the forested areas, impacting it negatively. Next. 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 Okay, there's two types of water pollution. One pollution is called point source pollution, and that's a water pollution that you can trace, or you can identify where the pollution and what the pollution is coming from and what the pollution is. Next. Next. And then back up. So the second pollution is called non-point source pollution, and that's a water pollution that you have an idea where it's coming from, but you can't pinpoint the source. An example shows a parking lot. You know, we got a lot of vehicles that are on the highways. You know, when they get parked on parking lots, some of them, you know, they're being driven around leaking oil, antifreeze, power steering, brake fluids, and that leaks onto the parking lot. And when you get some precipitations and you get a runoff occurring, and that runoff is going to pick up some of the pollutants off of the parking lot and carry it into nearby stream, rivers, and lakes. So this pollution, you can say it's probably coming from the parking lot, but you're not able to identify whose vehicle it's coming from. And that's what non-point source pollution. Versus point source, you can see the building, and you can see the pipe, and you see the pollution coming out. So this one, you know where it's coming from. This one, you have an idea where it's coming from, but you can't pinpoint the polluter. And the non-point source is what I'll be talking about the rest of my presentation. Next. We get, you know, during this winter, you know, precipitation we get during the winter, the monsoon rains, and then when the snow starts to melt in the spring, that's when we get runoff. There's, you know, two different times of the year that we get runoff. Next. So this is the springtime runoff where the snowpack are melting, you know, running off the mountains, going into lakes, streams, and some, you know, they go down to washes and they end up either in San Juan River or the Rio Grande. Next. And this is some pictures of water runoff occurring on the Navajo Nation. So this is from the monsoon rain. And this is a lot of water leaving the reservation that we don't realize. You know, the local general public don't realize how much water we are allowing to leave the reservation through runoff. And this is a lot of water. So whenever you see water running down the wash, down the road, that's water leaving your land. And that water is not coming back. until maybe next time the next storm comes in. So, but on Navajo, probably the last 20, 25 years, the runoff has really increased tremendously. And we don't realize that we're losing a lot of water through runoff and leaving the reservation, and we're not realizing that. And the thing to think about when you see runoff is, how can you reduce runoff? Or how can you allow less water leaving your land and more water going back into your groundwater, recharging groundwater? But the more water you're allowing to leave your land, that water is not coming back. And also, the more water runoff you have, you're going to have increased erosion activity, increase of pollution getting washed off land and carried into your stream, rivers, and lakes. Next. And then this is the Chaco River again. This is again the water leaving the reservation. Next. And then this is a picture of the Grand Falls. That's again water leaving the reservation. And notice that it's the color of the water, it's brown. That's clearly showing us that there's a lot of erosion activity happening. And erosion is basically water washing soil off your land, and when that is happening, you're allowing runoff to decrease the amount of topsoil you have. And when you lose your topsoil, all of it, your soil is not going to be able to grow plants in those soils. So that's something that we just need to keep in mind, and we need to, at some point, from now till the next 300 years, how can we reduce that? And if we don't do nothing about that to reduce runoff and to reduce amount of soil leaving the reservation, we're going to be really in a bad situation. Not we, but our future generation 100, 200 years from now. So there's something that we need to really think about and start thinking about how can we do, watershed management on Navajo. There's really no activities or it's not on our government's priority list to start really encouraging and focusing and making it a priority to start doing watershed management. Next. And the more increased runoff you have, the stronger the velocity of the flow is going to get, and then that also causes a lot of infrastructure damage, flooding, and any water damage it causes, it's always going to be very expensive to repair. Next. Again, the more water runoff you have, it's going to impact the environment, it's going to impact the water quality, and also impact some of the, the water species, bugs or critters that live in stream, rivers, and lakes. And this is a slide that shows what type of critters we have in our stream, rivers, and lakes. These bugs are called benthic macroinvertebrates, but for short we call them stream bugs. And our program also does sampling of stream bugs to determine water quality. And how we do that is, how we determine how good waters are based on stream bugs. If you have mayflies and stoneflies in your stream, rivers, and lakes, that's a sign that your water quality is pretty good in that stream, because these bugs are very sensitive to pollution. And if for some reason they're not in your stream, rivers, and lakes, that's going to tell you that there's some type of pollution that had caused these critters to be either killed off or they moved downstream. The middle category is somewhat tolerant. These are critters that will live with some pollution in streams. And then the last category is very tolerant, and these are critters that will live only in very bad water quality streams, rivers. So you can, these bugs will tell us how the water conditions are. Next. Back to the other slide. Another thing I forgot to mention is these bugs are food source to fishes. And the fishes are food source to wildlife, birds, and humans. So just because of a lot of sediment, eroded soil going into this stream where these critters are living, when the sediment starts to build at the bottom of the stream, it starts to cover grasses that grow underwater. And when those grasses get covered by sediment or soil, it cuts off these guys' food source, and they'll start dying. And that impacts the food source for the birds, the wildlife, and human as well. So, You know, sediment is a very, it's a very powerful pollutant that we don't realize that it exists. So on Navajo Nation, the highest non-point source pollution getting into our stream, rivers, and lakes is soil, sediment. And we don't realize that, but that's the highest pollutants that we know on Navajo is going into our stream, rivers, and lakes, and it's impacting the land, the water quality, the streams, the lakes, and also a lot of the sediment coming from runoff. A lot of that goes into your floodplains, your cornfields, and it really degrades the quality of the land. Next. On Earth, how much water do we have on Earth? Where are they at? 97% is in the ocean, 2% polar ice, 0.6% fresh water, 0.4% groundwater. So this is the two type of water that we rely on as humans to survive. So if you combine the two, only 1% of water on Earth is fresh water. The rest is polar ice and ocean. Next. 2 ways water is taken from the ground on Navajo. One way is by windmill, but that only works when you have, windy days. In some parts of the reservation, there are a lot of winds throughout the season, so it's good in a way. But this water system, this way, this water is taken out and put into tanks, into troughs for livestock only. It's not for human consumption. Why? Is because this water is not treated at all. It's directly from the ground into the tank and into the trough. The second method is wells. It's taken out, then it's treated, and then into the tanks, and then to people's homes. Next. Okay, the non-point source pollution generating activities on Navajo Nation. These are activities that I'm going to talk about, and these are activities that we know on Navajo is polluting the non-point source pollution. And it's degrading the quality of water quality, surface water quality. Next. The first activity that's generating non-point source pollution I'm going to talk about is, I'm calling it continuous grazing, but the rest of the reservation, they call that overgrazing. Which, continuous grazing to me, or overgrazing and continuous grazing. Overgrazing is self-explanatory. Continuous grazing is a new term that I'm using because continuous grazing is basically grazing in the same area for a long period of time. And that long period of time could be more than 50, 100, 150 years of grazing in the same area without any rest for the vegetation to regenerate itself. So continuous being grazed year round, in and out for decades, for a century. At some point, by not allowing your grasses to regenerate, you're going to lose your grass cover. And when you lose your grass cover or lack of grass, that's when bad things starts to happen to your land. Next. So this is some slides that's going to show what continuous grazing is. Next. So you got a piece of land with some grass, and you got water here. It could be a stream, river, or a lake. And you got your sheep, cows, horses. So every year in the springtime, when there's livestock, when they have newborns, that just means there's more animals that's going to be grazing in this area. The more grazing in the same area, the more you got, the more they're going to eat, and the more areas, piece of land that they got to graze to continuously have vegetation cover. But if there's a whole lot that the land cannot sustain the number of animal grazing in this area, what's going to happen to your land is you're going to lose your grass cover. So when your grasses are gone, or you've got a lot of bare ground, then when you get rain, when you have less grass cover or no grass, when you get rain, due to lack of grass or no grass, you're going to start losing half of your rainwater to runoff. So that means half of the rain coming down is going to end up leaving your land, and half of it's going to go into the ground, or either into your stream, rivers, and lakes. And with that happening, lack of grass, too many animals grazing in the same area forever, you're going to start losing grass cover, and that's when your animals are going to start being hungry, starving, prone to diseases. And because of, due to lack of grass cover and too many animals out there, you know, that's one of the reasons why some of the livestock on Navajo Nation end up within the right-of-way areas, along the highways. And when they get along the highways, you know, they become hazard to people driving on the road, and then eventually some of them become roadkills. So those are things that we don't really realize, that having livestock and without management, just focusing on the numbers you got, wanting that number to grow, you know, we don't realize that that's impacting our ground, soil, vegetation, and our water quality. Next. This is just a slide that shows a lot of horses in one area, and throughout the reservation, you know, we all know now the conditions and issues of overpopulation of feral horses, and that's also impacting water quality. And as I explained earlier, of how having too many animals in the same area for a long period of time, how that impacts the water function. Next. And then this is a photo that shows a roadkill. And it's sad to say that to us Navajo living on the reservation, this is almost starting to look normal. We accepted it, that it's okay. But think of your animal. People who have livestock, you know, why do you have your livestock? Are you eating it, or are you just having it so that you have money to when you take it to auction? So we need to realize that the animals, the livestock that we have, we should be using our livestock to manage our rangelands. But the way it is now, no management, I just want more and more and more, we have forgotten our land condition. And due to not really doing no type of management, it has started to impact our surface water quality. In Navajo we say tobe'ina, or in English, water is life. So by allowing no management to rangeland, losing grass cover, increased runoff, allowing water to leave our land, you know, when we say tobe'ina, or water is life, you know, we're just allowing water to leave our land. And another way of what I'm trying to say is, you know, we're just allowing the life that's in the water to leave our land, and we need to think about our future generation. What are we going to leave behind for them? Next. And then this is algae. This used to be a perennial stream, and it still is, but it's just a trickle now. And the green is the algae. Algae in streams is an indication that there's a lot of nutrients getting into the stream, which on Navajo, nutrients are most of the time coming from livestock waste. Cows, horses, sheep, whatever animals we have on land, you know, they come to drink here, and they poop and they pee, and eventually gets washed into your streams, your rivers and lakes, and that's where your algae are coming from. Another thing to keep in mind is when you see algae, you need to think about some of that water is going into the ground, eventually getting into our groundwater, and then it's being sucked out or welled out, and it's getting into, maybe it could get into our water supply, our drinking water supplies. Next, a drawing that shows land and underground, two different type of land. This is managed, unmanaged. When you manage your land to have adequate grass cover year-round. So it says up here, more plants, less water runoff. So over here, the upper half, you have adequate grass cover, and when you get rain, there's less water going into your stream, rivers, or less water running off, more water going back into the ground. By less water running off, that means less pollution and less sediment goes into your stream, rivers, and lakes. But if you, the bottom half, you have no plants or less plants, that's going to cause increased runoff, which means by more water running off land, you got less water going back into the ground, recharging groundwater, water tables dropping, and more water leaving the land, also taking along topsoil and trash pollutants into your stream, rivers, and lakes. So this slide is telling us that the more vegetation you got, or The amount of vegetation you got determines how much water is going to run off your land or how much water is going to infiltrate to recharge your groundwater. So the good thing to have is the more vegetation cover, less bare ground. That way you have less water running off, more infiltration. Water is not leaving your land, it's going into your groundwater, which becomes, you know, drinking water for the future generation. Next. Rotation grazing, one method that's very effective to sustain your livestock to have adequate grass cover year-round is, you know, rotation grazing. An example shows, you know, an area of land that's fenced off with pastures, but this only will happen if you reduce the number of animals you have based on how many pounds per acre your land can produce. So with that, throughout the reservation, in order for us to get vegetation back, we have to reduce the number of animals we have, so that allows the plants to grow, to produce seed and regenerate itself. As long as we're not allowing the grasses to regenerate, we're just going to continue to lose grass cover and increase runoff, increase of sediment being washed into stream, rivers, and lakes, and water leaving the land. Next. And this is a way to determine how much pounds per acre your land, your grazing land is producing. And all they do is you do a grid with an acre plot, and then every so often you drop this mesh down and you cut the clippings of your grasses, and then you do another one, and when you do the whole acre, you weigh that grass, and that's how much pounds per acre your land is producing. Some numbers I'm going to give out. One sheep eats 9 to 11 pounds of grass a day. Cow is 14 to 16 pounds of grass a day. Horse is 19 to 21 pounds of grass a day. So BIA did a vegetation study on Navajo. I won't say where, but they did a vegetation study, what I just showed here. And the result was a piece of grazing area on Navajo was producing only 11 pounds of grass a year. So if your grazing area is producing only 11 pounds of vegetation a year, that means you should only have one sheep in that acre to graze 1 year. And it's going to have its adequate amount that they need. So these numbers that I just mentioned is very surprising. It's like scary, like, oh wow, how can we be doing that to our land? So if you have 100 acres of land, and if you have adequate grass cover, you should only have one horse in there, or a cow with the calf, or 5 or 6 head of sheep year-round in that 100 acres. That's if you have adequate grass cover. But if you don't, if you're only producing, like the survey BIA did, you know, 11 pounds per acre per year, that's amazing, man. That's only calling for one sheep in that 1 acre to graze 1 day out of the year. Okay, next. What can happen if you manage your rangeland, or if you want to improve your water quality, your rangeland, and your cows? Take your cows away from this area, no grazing, but for this area, they still have the wildlife in there. But the guy wanted to improve his conditions, cattle, rangeland, water quality. He took these cows off for 4 years. 4 years of letting the rangeland regenerate itself. After 4 years, that's the same area. This is just allowing the grasses to regenerate. Some people say that this can happen on Navajo, but we see this happening every day when we're driving the highways throughout the Navajo Nation. Within the right-of-way fences where the highway is, I mean, we got grasses that are this high. On the other side of the fence, there's bare ground or hardly any vegetation. So if grass can grow inside that right-of-way fence, grass can also grow on the other side. It's just allowing the grasses to regenerate. That's 4 years. What's 4 years? Out of thousands of years that we're going to be on this land. Next. Another way that water gets polluted is by driving off-road, creating dirt roads with vehicles and ATVs. Next. Nana. Next. Okay, so every one dirt road you're creating out there, driving around, shortcuts, people using vehicles to herd sheep, people using dirt road or creating dirt roads to look for their livestock. We do a lot of things that we never used to do 50 years ago with vehicles. So why this is creating pollution, getting into stream, rivers, and lakes. One dirt road you establish, you have created 2 trails where water is going to leave your land. You got a second road that you put in, you're going to have 2 more trails where water is going to leave your land. So every new road you're putting in out there, dirt roads, every road you're doing, you're creating 2 trails where water is going to leave your land. So if you got one road coming to your house, that's 2 ways water is going to leave your land. If you got 10 roads coming to your house, that's 20 ways you're allowing water to leave your land. And you know, I've seen places on Navajo where there's like 2, 3, or 4 homes and there's like 10 ways to get there. And that's just allowing every road you're doing, like today, someone on Navajo is probably creating another dirt road. And that's also adding 2 more trails where water's going to leave your land. And another thing about dirt roads is wherever you create those dirt roads, water can't infiltrate. Plants can't grow because the ground is so compact. So any bare ground that we have, those are areas where we have increased runoff, increased erosion, and decreased infiltration. So one way that we can prevent this from happening is we have to stop making new roads. We have to try to stick with one road. So how do we slow down from making new dirt roads? People who herd sheep, people who have livestock, they have to start using horses again instead of using ATVs or vehicles, because if we're thinking water is life, if we're thinking of our future generation, we got to start doing these little things that's going to, you know, reestablish vegetation so that allows, you know, less water runoff, less erosion, and increased infiltration. Next. Like I mentioned earlier, two trails, compact trail, rain, that's where water is going to leave your land. It's going to hit to another road, down a wash, and it's leaving the reservation. And what happens also when you put a road up a hill, before these roads were put in, when water came off this hill, it used to be distributed down the whole hill. But if you put a road here now, this water is just going to go to the road and leave land. This area is going to go to the road and leave this area. So the water that used to be distributed along this whole hillside is now being diverted off just because of roads being put in up that hill. Next. And this is one road maintenance that's very effective to keep your stop from your water leaving your land, or you know, your roads not to get so muddy when it gets rain, is to take the waters off the road. And you can do a rolling dip here to where you kind of scoop some of this soil, dirt out and make it berm. So the water coming off down this hill goes off the road and pools here, and if a lot's coming in, it's able to go over this berm and it's spread it out through the rangeland along the dirt road. And it also decreases the amount of water running down this road and also pooling up down at where the low point is. So it's one very effective way to manage water and to maintain your dirt roads. Next. So if you have to do a dirt road, good thing is keep away from meadows. Bad thing is down the middle. Worse is when this gets deep, you do another one next to it. Next. Natural watershed. Adequate grass cover. No roads, no construction, or better management or better development of roads and buildings. If you get rain, 50% will go into the ground, 10% will run off, 40% will go back into the water cycle. The same area but developed, now the same area but it's developed. 100% rain, only 32% goes into the groundwater, increase from 10% to 43% water running off. So this is where increased runoff, increased erosion, increase of pollutant getting washed down into stream, rivers, and lakes, and then 24% back into the evapotranspiration. So this is telling us that anywhere, any place that you change the landscape, you can also change the way water used to function. And the result is always going to be increased runoff. So this is where we really encourage, best management practices, when we're doing developments. Next. Another is improper road drainage design, not placing culverts and bridges in the wrong places of a wash, or, rediverting natural channels to a different place. So this is 3 distinctive streams or washes. So the improper, go ahead. The wrong way to build a road through here is divert this water along the highway, just blocking this off, and the water ends up along the highway. By doing this, you're cutting off the flow where it naturally used to flow, so this starts to dry off. And then where the water is diverted along the highway, you're going to have higher erosion activity, and then also gully formations, and all the sediment that's going to be washed off of here is going to end up downstream. And if all this drainage area is diverted into just one release area, one big pipe, your velocity is going to be higher, and you're going to have more erosion activity downstream from the highway. So this is improper road drainage designs. Next. So this is another thing, is placing your culvert at the wrong elevation. There's a culvert in this hole that allows water from this side of the highway to go on the other side. And the correct way to install the culvert is you should be able to see the whole pipe. Let me see here. So what I'm saying here is, when you're putting a culvert below a road, it could be dirt road or it could be a highway, these culverts are designed to be installed one way only. And that one way only is, you should place that pipe on top of your land, and you should build your road over it. Where people make mistakes is they dig out a trench and put this below grade, and they build their road over this. By putting it below grade, the depth that you put this pipe below ground, it could be 1 foot to 6 feet deep. And let's say 3 feet deep, you put this below grade 3 feet. 2-3 years later, you're going to have a gully upstream and downstream from this pipe. So I'll show the proper way to install these pipes later, a couple more slides. But so this is the wrong way. Whenever you don't see a pipe, that's the wrong way to put it in. Imagine 2-3 years later from now, there's going to be a gully upstream and downstream from this pipe, the depth that this pipe is below grade. Next. So this is a picture taken from the inside. Next. This is the ground elevation. Next. This is the bottom where the pipe is at. So this pipe is this is a scale of one yardstick. So this is a photo that shows how deep the pipe is put below grade. So what I'm saying now is, the depth that this is put below grade, there's going to be a gully this deep going up into the woods and then downstream. And the sediment, the dirt that used to be in here, is going to end up downstream in our river, lakes, and ponds. Next. So this is a drawing that shows natural grade here, the highway's there, but the pipe is put that deep below ground. Next. So when you get runoff, this water coming out of the pipe is going to continue to erode away and create a gully all the way downstream from here, and it's going to be that deep. So when water is going off of a higher grade, that water doesn't just go shoot down and then this way. That water, when it drops to a lower elevation, is going to drop, and it's going to scour, turn back, and turn this way. So where the water is going like this, that is where it's eating at the soil, and that's how it's dropping it. So But if the pipe was up here, this gully wouldn't be happening. It's called gully formation. Another word is head cut. Next. So this one is showing a pipe culvert put there, and there's a gully. This gully is this deep because this pipe is that deep below grade. So that gully is going to be that deep because this is that deep underground. It's going to start head cutting or gully starting this way and that way along the road. Next. Another pipe that's below grade, the natural grade. Next. The natural grade is up here, and this is how deep it's below grade. From a little bit of maybe 20-minute sprinkle water coming off of this road and off this area, there's already a gully starting to form right in here. And that's going to just become a bigger storm. It's just going to make a bigger gully. Next. Again, natural grade pipe was put in that deep. So this process is starting already. When the highway was first built, this is how deep the pipe was put below ground. 20 years, that's how deep it got, and finally vegetation started to come back out, and it stabilized the ground. Equilibrium is what's happening. So then they redid the road, and then they put the pipe deeper, and now this 20-year process is starting all over. So next 10 years, this gully is going to be that deeper upstream. Next, this is a gully going into someone's cornfield. This is example of, this is telling us that there was a pipe that was installed that deep below grade. Next. Another photo that shows a gully forming along the highway. There's a shovel here for scale, so this is like about a 5-foot gully, and the pipe is down here that's put below grade at that depth. Next. Same thing here. There's a gully starting to come off the highway, going along the highway. Next. Next. This is a former co-worker. The dollar sign is not, he's not thinking about the money he's making. He's thinking of the amount of money being wasted on road maintenance due to improper drainage designs. Next. Again, culvert outlet is that deep below ground, and that's how deep the gullies are. Next. Is this another bad thing? Gabion baskets weren't installed properly. It blew out. Eventually, this whole thing is going to shift down, and it might even give out. Next. This is underestimating the amount of water draining off of land that's going to go through this gully. So this is underestimating flow, drainage area. If they could have done maybe 4 or 5 pipes this size, this wouldn't have happened. Next. The proper way to install culverts. You should be able to see the whole thing. Next. Another proper way to install a pipe. Next. Another proper way. So you're seeing the whole thing. That's the correct way to install culverts. Next. And then again, construction going on. You can see the culverts. Compare that to the ones that I showed earlier. You can't even see the pipes. Next. Another activity is irrigated agriculture, using water to farm. Using irrigation to farm. The only place that this happens is at Nampi. The rest of the reservation, farmers, they use the method called dry farming. Next. So how is that generating non-point source pollution? So in Nampi, what they do is they spray chemicals on the crops to get rid of pesticides, herbicides, and fertilizers for the plants to grow fast and big. So when they apply that by airplane, the chemicals are being sprayed on here, and then after it's sprayed, then when it's irrigated, some of the chemicals ends up being washed off this field, and it could be getting into our nearby stream, rivers, and lakes. Next. And if some of that chemicals are being washed off into nearby washes, it can get into our livestock watering and also our shallow wells. Next. A very serious activity that we probably all know about if you live on the Navajo is illegal trash dumping. Very simple. We should be taking the trash we generate at home. We should be taking that to the transfer stations within our chapter areas, or if you live nearby a town like Gallup or Farmington, You know, some people, they take their trashes off their reservation to the proper landfills. But throughout Navajo, you know, most of our washes are like this. Almost maybe all of the washes on Navajo have been dumped illegally into. And all of this that we're dumping, they get washed downstream and end up in our stream, rivers, and lakes, and that impacts the stream, the rivers, and the lakes, and also the livestock and wildlife. Next. So, some of the illegal dumpers, they dump their trash, next, then they light it up and drive away thinking they're getting rid of their trash. So, even when you burn your trash, see, when you light it up, the trash becomes flame, smoke, and heat. And when you burn it off, people think that they burned their trash, that they got rid of it, but inside, in the ashes, you still got chemical and toxics that didn't burn off. Next, and when you get rain, those toxic and pollutions, you know, they end up being carried downstream to your river, lakes, and ponds downstream. And the livestock around here are going to be drinking the stuff that you're burning upstream, and that's not a good thing. Especially not a good thing if you're going to be butchering a sheep that's drinking at this pond. So things to think about. So please, Navajo people, take your trash to transfer station, even if you got to pay, or you can take it to border towns. You know, if everyone on Navajo was taking their trash or the waste that they generate to transfer stations or to border town dumping areas, Navajo should not have this problem at all. If everybody was doing this, Navajo washes should be clean. Next. But if you're dumping fluids and stuff also in the washes, eventually some of that's going to start going into the ground and make it into our groundwater. And if a lot of it's going into our groundwater, you know, it can end up in our drinking water supplies. So please take your trash to transfer stations, even if you got to pay, just so that, you know, our washes aren't being dumped into, and that's so that it won't impact our drinking water for the future generation. Next. And then this is just some pictures that show what some of the areas look like. This person that was dumping here, he said he was doing this for erosion control, and this is not a way to do it. Next. And this is just whatever we dump or leave on land, it's going to end up in our stream, rivers, and lakes when we get good storms and heavy runoffs. Next. Again, another photo that shows that. Remember, the stream bugs that I showed earlier, this is their habitats. And if we're allowing these pollutants to get in there, it's going to impact those benthic macroinvertebrates. Next. And then this is another site that we see throughout the reservation. You know, livestock drinking, eating, plastic, trash, bacteria, chemicals at people illegal dump sites. Next. 1 gallon of oil will contaminate 1 million gallons of water. So if you're going to change your oil at home, buy a container from Walmart, AutoZone, drain your oil into that, and Gallup, you can take your containers with oil in it to AutoZone and Pep Boys, and they'll take your container, pour out the oil, and they'll give you your container back, and they won't charge you anything. Next. Okay, everything is impacted downstream, runoff, even if you can't see it. So whatever the watershed that this lake is collecting water from, if those areas are illegal dump and a lot of sediment is coming off due to lack of vegetation or excessive dirt roads, it's going to end up in our stream, rivers, and lakes, and it can also impact, you know, the fishes, and we're at the end of this fishing pole, it's going to impact us. So people, please start thinking, you know, how things that we can change that can improve the water quality and also the land environment. Next. Reports that are required from us to turn into our funders, US EPA. These are some of the reports that's, you know, we got to do every 3 years. Some of them are 5 years. Next. Some of the results from some of the monitoring that we're doing. 86% of impaired is, this impaired mean is not the way it used to be, it's gotten worse. In many tribal lakes is due to non-point source pollution. Next. 95% of impairment identified in rivers and streams of the Navajo Nation is also due to non-point source pollution. Next. So please help us protect and preserve the waters of our Mother Earth for ourselves and for the future generation to use and enjoy. Next. Thank you for listening and looking at this video. And please think about water and think water is life. Tobe inata. And thank you and have a safe drive home. Remember, Tobe ina. Water is life. Yeah.